come on, it's the moment we've been waiting for. He's a keynote about data's deepest core. With wisdom and insight, I'm sure to amaze. Dr. Mühleisen is in the spotlight's place. It's about changing the world of data streams. Growth, change and grow, fulfilling analytics dreams. Changing large tables, the journey begins. To rethink the way transformation truly wins. Thank you. Hey. Good morning, everybody. I have this is for me is very new that somebody makes a song about me. So I'm really grateful. This is so very sort of frazzled right now. So I just have to process that. But while we do that, the clicker works. Yes, excellent. So I'm here today to talk about changing large tables. I'm also going to talk a bit about big data. But I'm really grateful to be here. We of course are in Holland, and very often we go to America to give talks, and that's all nice. But I'm really happy to see something like today happening in Europe, specifically in France, where a lot of stuff is happening, but it's just not always so visible. Maybe you need to be better at shouting. I don't know. So I'm going to talk about tables. I said I'm one of the people behind DuckDB. I'm also a academic researcher. I'm a professor of data engineering, but so I'm going to try to keep that a bit at bay in my talk and focus more on some of the higher level concepts. So before I start, I like to show this wonderful table here. So this is a table that is about 5,000 years old, and it was found in Mesopotamia. And I like to show it because you look at it, you can kind of see the Excel table, right? And it has been translated, thankfully, and people have been tracking very important data on there. Amounts of hop and barley, we can only guess what they were making, right? But the thing is that I really found fascinating about this table is that it predates the written text by about 1,000 years. So tables are a civilization technique that is older than writing things down. You're just like that sort of sits, because sometimes you think, tables, databases, it's also new, but it is actually not new. This is something that has been around before we knew how to write down a story. So this, in case you ever need any sort of justification why you like tables, there it is. But to get the duck-sized elephant out of the room, indeed, as Christoph has said, I one of the people behind DuckDB. Many years ago, we started this project that was meant to make sort of working with data easier. And I just want to do a quick show of hands. Who is here using DuckDB? Okay, great. And who has heard of DuckDB? Okay, most people. Very good. So I have some work to do today. But in a nutshell, DuckDB is this in-process analytical database management system that is sort of built to be easy to deploy, give you a good sort of analytics experience without sort of having to set up a huge amount of data set. It's a SQL system because, we really like SQL. And it's been quite popular. It's the fastest growing data management systems project, I think, ever, from what I can see. And again, it's a European invention. This came out of publicly funded research in the Netherlands that we eventually spun off into a company where I work now. But the mission of DuckDB is really to move people from fear to confidence. And this I have to explain. I think from my interactions with people and practitioners is people generally are afraid of data sets, especially when they become a little bit larger. And it seems to me that the fear generally starts when things stop fitting in Excel. Okay. Then it gets a bit like, oh, what do I do, right? Should I spin up a Spark cluster? Maybe that's too much. Should I, throw pandas at it? It becomes a bit difficult. Then you're sort of asking for issues with a CSV parser. You're kind of, it's just getting this a bit, you get into this, I personally get into this mode where until this thing has been sort of processed, I'm still expecting the worst on line 4,872 of a data set. And DuckDB is really trying to change that. So we are working really hard to basically make it easy, make it convenient to work with data sets that are quite big, and And that's the mission. So that was just very briefly about DuckDB itself. And now I want to talk a bit about one aspect of DuckDB's design, which is big data ? So when we started DuckDB back in the day, there was a sort of common wisdom that in order to process data, you needed a big distributed system. Okay? And there's some issues with having a big distributed system, like sometimes it can be very difficult to use a big distributed system. It can be very expensive. It can be very inconvenient. It's hard to debug, these kind of things. It's hard to get started. So we went the other way. We said, we'll go single node. And let's have a look how that worked out. This is a bit hard to read. I think, can you see the line? Yeah? Okay, great. Note to self, don't use yellow anymore. But if we look at the sort of this very scientific chart, I'm a professor, hey. But then we have the past, we have today, we have the future, and we have this line that shows 99% of scans. What does that mean? That is the amount of data that a data task, let's say analytics task, has to read in order to complete. Yeah? So it's not the data set size, because modern data formats actually don't require you to read the whole thing every single time you want to do an analysis. So it's the amount of stuff that's actually being read. So the 99% of scans is going up, but it's not going up so quickly. What people forget is that hardware is growing much, much, much faster than that line. So the capabilities of what you can process in terms of data questions on a single node is going up faster, is something I claim. Okay, so we'll see how that goes. And of course, in the past, the distance between what we could do in a single node and 99% of scans would be bad. So like 2001, that would not really work out. Today, it might be less the distance. And at some point in the future, we will have the data singularity where, basically every data question can be answered on a single node. We'll see whether we get there. But interestingly, people have recently published research from both Redshift and Snowflake, two of the biggest data warehouse as a service companies, that show that the median scan of data uses 100 megabytes of data. Okay, the median scan for a query that does some analytics thing is 100 megabyte. That's not a lot. That can probably, if you wanted to fit on your watch. And the P 99.9, so not even 99%, it's the 99.9, was under 300 gigabytes. And so that's something that fits on a MacBook. And so we may even have already, crossed this threshold of the data singularity. I'm not entirely sure, but I'm quite happy about this because it means that our sort of prediction from 7 years ago to make a data system that works exclusively on one computer was maybe not entirely wrong. And if you want to read more about this, there's a great blog post by Jordan Tigani, the founder of MotherDuck, who has been product manager at BigQuery for a long time, and has written this very nice blog post that explains this in a bit more detail, a bit more elaborately, and a bit more detail than I could here. So now I have argued that maybe the data sets aren't that massive. And if the data sets aren't that massive, maybe some of our trade-offs can change. Like in the past, we traded off everything for sort of vast crunching capability. I don't know if you remember, but there was a time in the past where we threw away everything and rewrote our data pipelines in Hadoop. Who has written Hadoop pipelines? Did you like the experience? No. So the thing is, we traded away a lot of convenience and sort of capabilities in data pipelines just for the sort of the vast and the raw scale capabilities. But if maybe the data sets aren't that massive anymore, and maybe if the single node capabilities are actually growing quickly, maybe we can have some of the nice features of data management systems back. Okay. And one thing I think we have been sort of have not been spending too much time on in the last 10 years is changes. So change to data in a pandas data frame doesn't really exist, right? Like you load from your file, you make a transformation, and then you run that again next time. if you like, there is the tooling, the same for Hadoop, that the tooling has very sort of adverse to change. We've been taught to sort of use write only, write one storage like as free and basically just make infinite copies of our data sets. If you use something like dbt, it runs these endless chains of create table as select from blah, 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 which is really the opposite of change. It's just like making new data sets all over and over. So yeah, let's see what we can pick. So maybe we can do analytics on acid. That sounds really nice. I'm from Holland, so, and for those of you who don't know what acid is, it is a set of principles that comes from database, sort of, old time database sort of principles about how we deal with change of data. And I'll just give you some example. So atomicity. Here is a great example from an analytics sort of use case. And I really like SQL, so I'm going to subject you to some SQL. I hope you don't mind. Your data conference, you probably have seen it before. Here's just two queries, a simple transaction that creates a bunch of tables from CSV files. And you would say, okay, great. What is amazing about this? You can read CSV files. This is, by the way, a valid DuckDB syntax. You can just use a file name in the from and it will just work. But the cool thing is we wrap that all together in a atomic transaction. So if this fails halfway through the 37th file, nothing will happen, right? The entire thing will be rolled back and you will not have any changes. You will not see any changes to your data. That's really cool. That means you can have these atomic changes that, something like Spark, when you're writing somewhere, doesn't really support that well. With consistency. Why is consistency interesting? Well, again, we've been ignoring this because actually maintaining a primary key is a computational challenge for sort of complexity reasons. But if you think about it, it is actually quite useful to have something where, for example, in this example, we have a table with a primary key and we're reading a bunch of updates, maybe updates from today. I think I got the date right. Yes. We read a bunch of updates from today, and it will actually not go through in any way if there is a violation of this primary key. That's something we can do if data is small. And it's really nice to have that in an analytics pipeline. Isolation. Why would you want isolation? You're the only person sitting in front of your computer. Why would you want to isolate yourself from yourself? That seems schizophrenic. But if you think about it, if you have something like a dashboard running and you have background refresh, which is basically every now and then you have to update the data, maybe compute some derived things, having isolation between processes that change the data is a really nice thing. And so here in this example, we have the insertion on the right side that changes the data. On the left, we have this query, and they can run completely independent from each other. It's actually a hard problem, and in DuckDB, we invented the first analytics optimized multi-version concurrency scheme that makes this even run efficiently. And durability. I have a very short anecdote I want to tell you here. Anybody recognizes this? No? So this is a piece of network equipment that I have in my house. And it broke. It bricked itself and the power went down. And I was very upset about this. And it turned out that I'm not the only person. So this is just a few of the pictures people have on the internet. And the reason it bricked itself was because MongoDB manages to not actually ensure durability of data that you've written to it. Because it's, performance. I don't know. So if you write something to MongoDB, you have to actually configure it to actually force it to the disk. And because they didn't do that, these devices brick themselves en masse. So durability is something that is really nice if you can just ensure that things are written to disk and remain there and come back on restart. So don't do this. Yeah. If you want to learn more about this, we've actually just written 2 blog posts on changing data with confidence and ACID, and this, what I mentioned, the concurrent transactions. So this is just, if you want to read more, please look at these blog posts. They are written that we attempt to write them in a non-academic way. Okay, finally, I want to look at something that you will have heard before is the lakehouse formats. And one of the things I want to complain about is lakehouses are beautiful. Yes, you can agree. I want to move there right now. But the sad thing is, if you Google lakehouse right now, the only thing you find is articles from like Databricks people. And that's a sad thing, I think. Anyways, Lakehouse formats. So you have probably seen Iceberg, you've probably seen Delta Lake. There's a bunch of these formats. There's differences between these formats, but in the end, they're all pretty much the same. They try to solve the same task. They want to give you a bit of ACID properties, but on an object store, okay, on something like S3. And I'm a technical person deep down. So, I wrote my first Iceberg file, and then I looked at it, and it looked like this. It's beautiful. They have a lot of GUIDs up there and a bunch of Parquet files and some sort of metadata here. And why is that? Well, it's because what Iceberg is doing, it's essentially allowing you to have a sort of transactional system of large tables on an object store with sort of taking into account the weird properties of an object store. So here, the way to read something, we have to get this pointer up there. We find a metadata file. We get a bunch of lists in a format called Avro that I don't recommend you touch. And then in the end, we get a list of Parquet files. And this is all quite well and all quite nice, and people are very excited about it. But it is essentially just replicating a feature, namely, dealing with change in my opinion, a sort of limited way. And I'm not so sure where this is going. So Iceberg in the end is just a layer of stuff on top of Parquet files. And I think it's only really interesting if you have no other choice for managing updates. Otherwise, probably a dedicated data system like DuckDB is better. But I do want to say, if you're using CSVs today, you should probably switch to Parquets. And somebody, I think, in the near future will make a open source data warehouse with separated storage and compute that hopefully will make the Lakehouse formats redundant. But we can talk about that in the comments. So that was it. Changing large tables. Big data is somewhat dead, I said. I hope you don't disagree too much. I would try to show that transactions are a great thing for analytics too, and expressed my level of skepticism for Lakehouse formats. So that was it, and I'm happy to take questions. Thank you.